So second talk. So Ivan has talked with us before a few times. Anyone remember the dinosaur suit?
Yes.
Yeah, that was epic. Fantastic. Show me about the audio. So Ivan's going to talk about Kubernetes, GitOps, strikeout, bold, whatever.
And hating people.
And hating people, of course. So I'll give it over to Ivan. Thank you.
So I always start the same question. Do you hear me?
No.
Yay! There's a camera here.
I have two microphones and you cannot hear me? I have a microphone here and a microphone there.
Yeah, but that's what you t-shirt.
What do you want me to do? I have to pull my t-shirts, right? So before I start, I'm going to show you something. Yesterday was my birthday, and my daughter wrote me this card. Very nice of her.
Happy birthday to you. Happy birthday to you. Happy birthday, dear Daddy. Happy birthday to you.
I'll get my t-shirt off now.
Don't tell me they got the numbers the wrong way around.
It is, yeah.
There goes the mic.
There goes the mic. So I'll try to shout, and if you cannot hear me, just grab me later and I'll tell the same. It's just bollocks, most of it. So first thing first, I work for Influx Data. We run InfluxDB, and we're hiring.
You got the market,
Who's hiring?
by the way.
Who's hiring? Everybody's hiring. Come on. Anyway, so this is classic digital transformation. This is the journey that we all have been there. Right? So the question is, shall I use Kubernetes?
Yes.
Yes.
But why?
Why do it mention you don't need to ask why.
Can I answer or just like that?
Oh, sorry, you asked a question. Yes.
No.
No. Good.
Thank you.
Pizza!
What are the pizzas?
Best talk ever. We'll watch again.
Okay. So this is what happens, right? You go to internet and then look at all these demos that people do, and they like all these talks like super fancy, and there's like, I'm going to do it. I'm going to do it. I'm going to do it. Almost did it. What happened? Why it didn't work? Monoliths and microservices.
All at the same time.
Monoliths win hands down always. Look at them. Look at them. Look at them. It is. See?
Anti-presentation.
Just. So when people ask me if they should use Kubernetes, I give them this advice. And this advice works for everything, not only for Kubernetes.
The worst thing you use it if it doesn't try a bit fucking hard.
Or just give up.
Find something else to do.
The other thing is important is to understand that Kubernetes is an eventual consistent system, and that means that eventual is not now, it is not this, and it is not always. And if you want something like that, that's not Kubernetes. The cartoon is good. This is where most of the people struggle with when they're in the class and they have not the state that they thought that they were going to have, and they're really upset because crash loop backup. So we declare the state, and then it will try to converge. That's the whole principle. It will try. It will try to converge. It will converge most of the times. Sometimes it doesn't. So the real question is, what is Kubernetes? Who uses Kubernetes here? All of you. Okay. So what is Kubernetes? Come on. Container orchestration. Well done. Like, who else is using Kubernetes?
It's the winner.
He's a winner. Give him a beer. That's awesome.
It's a bunch of infinite loops.
Yeah, but
Excellent.
It's a CV development tool.
As well. So I like to describe Kubernetes as an API. That's it. Very simple. We have an API. We have a contract between my application and my infrastructure. That's it. That's why Kubernetes is so good. That's why the adoption of Kubernetes has gone completely off charts, because we have finally an IPA. IPA? No. This is what happens when I drink this. God, man. So this is Kubernetes for like, it's very complex. Like this is it. You have an API, you have compute, and you have a state. What else do you need? Now you can see it in different ways. Now remember, the API has dimensions, and it has holes and bugs and things that were supposed to work slightly different. And yeah, so it is like, this is the real stuff. This is marketing crap. This is the real stuff, where the things fall apart. And but truth is that you can go and create your API for your business. That is the key. Like, you can define your API, because it's not only an API to manage your infrastructure. It's an extensible API. You can go and define APIs to run your reports and your users and all these other things that you, as an organization that makes money or not, want to do. If you don't make money, you will not do it for long, unless you have a lot. Yeah, like, we could talk about VC money for a while.
Earning money is a way of making money.
Let's not talk about money.
True. So, at some point, Kelsey tweeted this, and a colleague told me, oh, you were talking about this precisely. I say, because my point was like, we have to try to achieve that Kubernetes is invisible. Once your Kubernetes is invisible, you are in a good place. Like, your applications are not coupled to the cluster. You remember when we were talking about cattle, not pets, and all the container stuff? We have to apply the same thing to clusters. Otherwise, we will suffer the same issues, right? And remember that what happens if we have a REST API. You know, you remember REST, right? Like, we all have done all these exercises. It's about objects. It's about objects, right? And what happens with these objects, we define them in a particular way using this wonderful thing called YAML, right? That's why we create YAML, because what we're doing is to define the objects that the API needs. Right? And that's why then we go and create all these template engines to manage all the YAMLs, because why not? There's languages like Pulumi to try to handle this. Like, but we have done this before, right? Like, who remember Troposphere to generate CloudFormation? Exactly. We have done all these things before. We know that doesn't end well. But here we are, doing it again. So the idea of the API is very interesting, because then you can start placing things like, we can talk about being above the API and being under the API. And some are happier than others, but that's what happens. The other thing that happens is that we are giving them an API to all these developers to describe the application completely, right? Who doesn't know Kubernetes at all? Anyone? Everybody knows? Okay.
Just kidding.
No, that's it. I'm going to start just
Just testing the mic.
first row and not knowing Kubernetes, man. So why Kubernetes? Why suddenly Kubernetes? Well, I said that, right? Like, we have an API and allows infinite growth. When I say infinite growth, I'm saying like infinite, like cloud providers that say infinite compute, until it's not that infinite, right? And until they decide, like, actually, I'm going to switch off all these machines in the center because someone is mining Bitcoin and blah, blah, blah. Oh, so my infinite compute goes out of the window. Excellent. So let's look at an example of what is this approach of above the API and under the API, right? Like, above the API, we talk about applications. We have all these objects. We have stateful sets, and we have persistent volumes and persistent volume claims and all these kind of things. And under the API, we have all these other things like the storage class that allow us to define how to attach, mount, and format disks in a particular way, very precise way. Right? So this is the real stuff. This is what happens in real life. This is the YAML. Right? The important thing here is to understand we have a very clear line. This is the API that defines, you know what? If we can expose these services, you can consume them, and then we can honor that. That is the key of the whole game. We can work under the API, working and provisioning whatever we want here, and then people can consume it.
What about the chain of APIs you could end up with loads of different service providers?
Yeah?
That's the biggest thing that worries me.
Okay, well, we can talk about that. Or like, have you talked to your therapist about that? Like worries about explosion of microservices? So we can talk about this later. Let's move on, right? Like it is basically like that, YAML and bash, like the ops and devs fighting all the time, right? So is it complex? Is Kubernetes complex, really? It can be.
No, it's complicated.
It's complicated.
Complex is
Different.
different meaning.
It presents as not complex.
It depends, right? It depends. It depends on in which level you are. If you are in certain places and things don't work as you expect, yeah, understanding what happens, like the DNS, for example, is not trivial, right? So is it complex? Yes, it is complex. But at the same time, it's giving us a framework that you can define these three things, like the runtime, the configuration, and the context. And by just understanding what is runtime, what is configuration, what is context, we're in a much better position. So I use this table always when I go and talk with developers. Okay, tell me what are your runtime. Tell me what is your configuration. Your context, you might or might not control the context, right? That's something that's important. You can control the configuration unless you are dealing with secrets, and then maybe not, right? But putting them in this frame of mind helps them to understand what can go wrong and how. And so I always mention the same kind of. You told me it was working. It doesn't work. Do you switch on and switch off?
You have to start again. It's like Kubernetes. Destroy and create.
No, what he said is he came here is like just keep talking because there are no pizzas, so just keep talking. So.
Let's go to the bar.
So in the years that we were doing things with config management like Puppet and Ansible and Chef and all the things, we had something that had to basically orchestrate how things happen. Now we don't have to. We can do things like this, right? Like we just check everything into the cluster, and then we have the Readiness Pro and the Liveness Pro checking what's going on. And the key here is to understand that this guy only checks these two dependencies. Frontend will never check if the database is there or not, right? That is the pattern that we apply with microservices. And that this is the whole beauty of things, that we reduce the scope. Now, frontend only have to worry about the dependencies. Depending how you define and publish these dependencies will help you to do these things better, easier, right? Now, if you're going to run Kubernetes, the first thing you have to do is to sort out your upgrade story. This is the developer. Yeah, that's the project manager. Right? We know. We have been here before. We have been here for a few years. We know that if you don't have this, in a year's time, your certificate will expire and you're in trouble. And I know of 2 companies who call me like everything doesn't work. Like, yeah, certificate expired. Oh shit. We don't want to upgrade. All right, let's rock and roll. Right? Marcus. If you know Marcus, he basically treated this as well. Why the quality of the code is so terrible? Who can answer this tweet?
Because you've got infrastructure people to write the fucking code.
It is a way of answering that, yes.
We don't like to release control, okay?
So the paradigm of operators and control is basically understanding which problem are we solving. And it is very different to solve a problem that we can have at Influx and a problem that you can have in whatever company you're working. And I can define an operator that works for me that might not work for you because my assumptions in infra, like you.
What about vendor operators are worse than community ones?
Because they own the infrastructure.
So the next Kubernetes meetup, I'm trying to do exactly that. Bring a lot of people talking about operators, right? Like, but that's the thing. That's what happens. This thing is what happens in real life. This works for us. It might or might not work for you. Okay, that might or might not
Just use a stable set already.
go well with. Oh, God. I hate this slide, but hey. So I'll give you another example of an operator. This is an AWS operator that was supposed to be used to consume services in Amazon.
Where's the bloody code?
They're following the Kelsey Hightower no code, I think. I don't know. They said that they will release it next year at some point. One day, right? So if you're going to write an operator, just remember a few things. Like who is going to use it? How it's going to be used? Why are you going to use this? And when it's time to stop and say, like, you know what, this tool has done his bit, just like, let's shelf it and forget about this.
4 hours after you.
Yeah, pretty much. So how long, I was in Soho House, I don't remember. I created this RDS operator, right? And it worked very well for a few months, and then we decided to shelf it. And the idea is like, a developer will go and put a YAML file, of course, in the cluster, and that will go and provision an RDS database, right? And it was working very well for that use case. There were other use cases that they assumed that was going to happen that didn't happen. That's when things get complex. That's remember this. So this is an idea that we've been working in my previous job, in my current job, and like other people are trying to do, and it's basically a health framework, right? And like we're trying to basically answer this question of, is your application okay? And your application okay means several things for, like different things for different people. If I have my ops hat, it might be my services are up and running. If my application has, might be that my application is working as I expected. If I have my user hat, is that the thing does what it's supposed to do. Like my children, they don't do what they're supposed to do. Perception as well, right? So the whole idea of this is that when I lay out this design, a lot of people get like, why you don't do it in this other way? Why you have all these controllers running there? Why you don't have one big controller that does everything? Well, yeah, it's basically that, right? Like do one thing and do it well. And now if someone wants to check or change how the service controller works, like this is Python, you can do it in Go, you can do it in JavaScript, you can do it in whatever language, but it's a very small piece of code that the only thing it does is to check. When you create a new service, if you might need or might not need a new health check for that service. Right? And you can expose like, okay, what do we need to check that my services or my applications work the way that we want? We might want to have a whole functional test defined as an Argo workflow. Okay, you can have it. Like now we have the option of you doing that, right? It's about thinking who else is going to use this and then how we're going to use it. One thing that I want to point, though, is if you look at who is contributing to Kubernetes, you see all these people. And the majority of them do not care about your applications. Have you ever seen Amazon saying, oh, we really care about you, NGINX, going down? Or Google saying, oh, yeah, these portals that you're running, maybe you should do it like that. Well, what they say is like, use our services, right? Like that. So it's important to understand all these people have agendas. All these people are pushing for Kubernetes. There's a big chunk of people that are not part of them, and it's growing, right? But remember why we still have shitty secrets in Kubernetes. Maybe this has something to do with that, maybe. Anyway, for those who don't know me, my name is Ivan. I'm from Barcelona. I run a few meetups. I'm trying to reduce the amount of meetups that I run, and every time it happens that I add another one. I collect typewriters by accident, and that's totally true. I have a few. And I like fountain pens. If you want to talk about typewriters or fountain pens, just ping me. So now let's talk about GitOps. Who is using GitOps? One. Who has been using Puppet and Chef and Ansible and all these tools, right? Like, and where do you put all this stuff? In Git, right? Don't. Well, yeah, but it is. Source. Let's just leave it, right? So what is the bit that misses? What is the difference between what we used to do 10 years ago, what we do now with the GitOps way? Right? Oh, by the way, I said I'm from Barcelona. I didn't know that Git meant this. So I heard someone saying like, "Oh, you're such a Git," and now you English people try to make the effort of ignoring that Git has a meaning like that. And when I say you're such a Git, trying to put in my shoes and think how confused I was when someone called someone else Git.
So I'm running a whole hub of it.
It's like, are you calling him?
We've always been
But
hence subversion.
so what is a pull request? What is a pull request? Come on. And now they will say, can you please squash your commits? No, I cannot squash my commits. Thank you. How do you deploy? How do you deploy your applications? How do you do it? Come on.
Set image.
We SSH, and then we copy this jar file, and then
View control, set image.
yeah. GitOps is about doing Git push, right? It's about doing just that, right? You have different ways of doing it, or you can do Git push. What happens is that we have automation that will go to GitHub or Git and pull that and do something. So why GitOps? It's because we're providing a consistent way of managing the infrastructure. But not only that, because we had that before, more or less, right? These two things are the key. Git becomes the source of truth of my infra, kind of, but all the management is pushed to Git or GitHub, right? Who has access to your Jenkins to do the deployment, right? Now, you don't, because you do Git push to deploy. You don't need Jenkins deploying crap.
GitOps CI actions.
Yeah, right, like that's the whole point. Like what happens is GitOps enables automation. It allows the automation to happen. We'll see how, right? And this is basically the process we do. We like watch for changes and apply changes, or not. We can do a lot of things here. We can go and analyze what you're doing and decide if you're going to go to, this is not Jenkins, this is Concourse. If you integrate the artifact or not, and push it to Artifactory or not. We can decide how to get this configuration and deploy it in the cluster. We can do testing, QA changes brutally when you have GitOps and you have a way of defining the environment using a whole bunch of YAML files, and that's it. And then deploying the environment gets easy, simple. Just put these files there and let the automation happen. That's how the magic happens. Right? So we have these things, and because we're doing with GitHub, you have all these GitHub checks and the actions and the approvals and blah, blah, blah. And we have been doing this for many years. And I do a pull request and you review it, and then you approve it or not. And then things happen. Right? This is the history of our pain. Right? Like, does anyone remember App Engine? Yeah. What happened with App Engine? App Engine was basically that, right? Like what we have with serverless now is, but nobody likes it. Why not? Why people don't like App Engine? It's awesome.
It was ahead of its time.
It was just too soon, yeah.
Is it? Is it not because it created too much friction? Because doing things in App Engine was difficult?
A little tooling wasn't there. The tooling wasn't there. The mindset wasn't there. People were not ready to have this sort of pipeline.
Okay. It's yeah.
Today,
It only worked well with simple things.
2003, what was the safe management decision?
Sorry?
In management terms, it wasn't until 2015 when everyone else adopted it was a safe decision. If you're going to lose your place as a director, you're not going to put 3 million quid into Kubernetes.
So like it.
Doesn't
it was before 2015. I was in the home office. It was the government putting money in Kubernetes.
Yeah,
So yeah, I don't know.
but it's about management. That's the problem. We saw from the previous speaker, it's about the culture of management making a safe decision.
True.
That's the problem.
So, what do? We have all these things, right? The important thing is this: we have code repos and we have config repos. Now, this is the I've been waiting to put this slide. When I did this, my daughter was really into this thing because the piggy was eating the mint, because apparently it's a mint. Like, don't ask me why she thought it was a mint, but she didn't find strange that there was a pig on a bed and a dog just behind there. But she found really cute that he was eating treats. Anyway, let's talk about CI and CD. Random slide. CI and CD are completely separated. Yeah? It is not been like this because this thing has not been mature enough. That's why I have this slide here, right? Like to try to illustrate this. Like this CI thing, it's very new. That's why now, finally, we have the ability, like, we're going to separate these things. CI is about artifact lifecycle. We create artifacts. CD is about application lifecycle. Different things. It's about environments, right? You can see CD as dependency management. So if you're a developer or not, you probably have your favorite language or not, and you have a way of managing dependencies or not. Right? We have several in every language, right? You can apply the same pattern to deployments. Once you understand, okay, I'm in the dependency game, you can say, okay, my dependencies, I can change my dependencies in Go, and then I can go and compile it, and boom, it doesn't compile, right? Same thing, I can change my dependencies, just deploy them, and boom, it doesn't deploy. Sad days, right? Or it can happen that it compiles, but then my unit test fails, right? So like I deploy, but then my integration fails.
Or it compiles and your unit test passed, but it still doesn't fucking work.
True. Exactly. What it's saying is that you unit test or your integration test were shit, you should improve them, right? But the important thing is that that pattern that we have had for years in development, now we can apply that to infrastructure. Challenges. People will push back. You start pushing for GitOps, people will push back because we haven't done this for years and it works. Usually it's Jenkins, right? Why do you want to do it like this? They will complain. Now, one of the issues that you have when you want to move to GitOps is that you don't have the automation. How do you do it? Like this gentleman is doing. You automate something with people. Why? Because you're buying time. So when we move, in my previous job in a bank, when we moved to GitOps, nothing happened because the automation was not there yet. What happened then is that we will receive a Slack message and we will go and do the deployment manually. Right? That was not the important thing. The important thing was the interface, declaring the API. Now, we're going to do it in this way. People got used to it. In 2 months, we built the automation. It was just that. And then when you have the automation, they don't have to change, and you can just go and enjoy.
But he's checking it.
Sorry?
He was checking it.
Well, I mean, of course, you send a pull request. Someone mentioned like, okay, what are you deploying? I'm like, what? Well, of course, you have to check. But
Looks good to me.
so one of the challenges that we have with the GitOps model is how to promote the environments. How to go from dev to QA, UAT, staging, integration test. You can create as many environments as you want. How do you go from one to the other? Because remember what happens, you have configuration in Git that are very coupled to this environment. And usually what happens is that you realize that your artifacts are not right, and you have artifacts in the application space that belong to the cluster or to the cloud provider, and you have to start just separating and creating new artifacts. We have tooling to promote environments in Influx. We have something called Alchemy. We had something in the bank to do this. You will have to do something similar. Can we create an open source thing that does these things? Probably. I'm sure that between Scaffold, Jenkins X, and company, they will have something that will do it in many different ways, and nobody will agree on which is the right one, but that is the thing. So what is next? After all these things, what's coming? Something that they call progressive delivery, which is basically, we do git push, we deploy. This is basically a canary deployment 101. We deploy, we allow some people to access it and test it, and then if it works and they don't shout, we go and give more access and so on until everybody is accessing my new thing, right? That's canary deployment for you. But now we just came with a really funky name. And now the recruiters will say, like, have you heard about progress delivery? And like, how many years of experience with progress
So
delivery?
if you canary release could give some people an unfair advantage over others,
It's
allow your customers to beat other customers.
Regulated?
It depends. It depends on the space that you are. But so we were doing green and blue deployment a lot. It worked better than Canary. Canary, you can use Flagger for Canary, and it works very well. But so there are ways of doing it, right? But yeah, that's it. And at the end of my slides, this is the end. Pizzas are there. I can smell them. I used to put a lot of checklists, but I don't because now these guys have the checklist there, and it's actually is nice because I don't know where's. I lost my glasses. If someone finds my glasses, please. Where is it? Oh, so it gives you explanation of why you should get or not get these things, right? And I think that's a really good.
These are the guys with a really cool diagram with some
Yeah.
background as well.
So yeah, so this is
Troubleshooting diagram.
yeah. So yeah, that's it. Well, thank you. Sorry.
Previous slide.
Previous slide, please.
Next one.
I think everyone wants that KATest.io URL.
This one.
That one?
Thank you.
You're welcome.
Hey, good stuff. Any questions for Ivan? Everyone wants to be the pug.
Pizza. You can ask me while I'm eating.
Pizza?
What are you eating?
Thank you.
Okay, cool.
Happy birthday.
Thank you. Yay.